Perfect. Again, hello and welcome. Liquid Software webinar. We're going to talk about, yeah, here you go. This is me, Jay Baruch, Head of Developer Relations with JFrog, Baruch Sadogurski, and we're going to talk about the book, Liquid Software book, that you can find more information on liquidsoftware.com, and this is our agenda. With that, let's get started. Let's talk about what liquid software is. It's kind of a term, I don't know if you ever heard about it, probably not. And this is fine because this is why you are here. So let's start with defining the term. And the term comes from the concept of liquefying the software. And the process of software liquefaction is transitioning from bulk and rare software updates to extremely tiny and extremely frequent software updates. So tiny and so frequent that they provide an illusion of software flowing from the development to the update target. So we are going from having packages being delivered on trucks or ships or whatever analogy we're using now for delivering software, containers on a container ship, all the Docker story, to actually having such a tiny and frequent updates that they almost look like a flow of water from your faucet. It's a pretty picturesque concept, and I guess it makes a lot of sense when you think about it, but obviously there are a lot of questions to unpack, and that's exactly what we're going to do now. So first of all, is it something that should be applied to everything? Is liquid software works in any scenario or for any software? And the answer is no. There are obviously some scenarios in which liquid software and continuous update and those continuous updates of software can really be problematic. And we did like a mental exercise of coming with scenarios in which we think liquid software works and in which it doesn't work. And we got to conclusion that the scenarios when liquid software won't work, when continuous updates won't work, are really a marginal minority. I guess some can say, wait a second, what about an airplane updating its navigation software mid-flight? Is it a bad thing? What happens if the update is not good enough? And obviously that can have disastrous effects. We're going to talk about how we make sure that problems don't happen, but think for a second that there was on-the-ground update of the software. This is something that happens constantly. And the software that was installed on the ground had a zero-day vulnerability. And this vulnerability actually being exploited mid-flight. Now the question is, do you want the software to be updated and patched in flight? And the answer will probably be yes. So although you might select not to apply continuous update to such a case of updating aircraft mid-flight, the ability to do that can actually do much more good than bad. So those minority scenarios when the updates are not automated enough and you don't really need them, this is where there is nothing to do with continuous updates. When the updates can be automated and they are not critical, you might decide whether it's ethical and right to apply this. And sometimes the answer is yes, sometimes the answer is no. When there are manual updates, but you really, really need them, you obviously will be annoyed because you need to do manual work to have those updates ready. So sometimes you will skip them and sometimes you will do it. But the majority of the software, 90% of the software, can and should be liquid. Let's talk about why is that. Let's talk about three drivers for liquid software and continuous updates that we see today. The first is experience and desires of our customers. Well, the majority of us are in for-profit business, and those who are not still have customer or user or people satisfaction in mind. And this satisfaction dramatically changed. Something that was applicable in late 90s, something that was acceptable in mid 2000s, something that we are dealing now won't be acceptable in a very near future. And some of it's not acceptable at the moment because we want better experience, we want more features, we want better quality immediately, as soon as possible. And obviously, when we enter a scenario of a market and of competition, either in for-profit organizations or even non-profit organizations, there are still competitors there. We want to be those who provide the most features in the shortest time with the most convenience and the most quality to our customers. So that's use case, that's driver force number one. The second driving force, to introduce it, I will point you to an amazing study that is done every year for I think like 5 years or something, which is called the State of DevOps, and that's by Dora Institute DevOps. I I keep forgetting the acronyms of Dora, and it's not really relevant because Google Cloud actually bought the entire Dora Institute recently, so it's now part of Google Cloud. I hope they will continue issuing this State of DevOps report for next year as well. But even last year, 2019, is provide us with a very interesting insight of why continuous updates and liquid software is so important. So what they did, they compared different teams, and there is a methodology stands behind it, which is really scientific research. And you can see here that group of elite performance do better from comparing to low performance in every aspect of software development. But the most interesting part for us here, when we when we actually discuss the liquid software and drivers for liquid software, is the correlation between how frequently an organization deploys to how fast they are capable of recovering from incidents. And this correlation is not something that should be surprised, because when you automate your processes and you release faster and you actually have continuous update practices that can update your environments whenever you want, you can actually achieve both. You release your new features and updates faster, and that obviously goes to the first driver of having a better customer satisfaction, but you also can recover from problems faster, because in the end, it is exactly the same operation. You roll out a new update, and the only difference is whether there are new features or fixes or rollbacks or what's not. So what we are talking about is not only we want our customers to get new features, we actually want to recover faster from problems, and this also requires continuous update in liquid software. And the third driver for liquid software is security. So I don't know if you remember, it's old news by now, but about this time last year, a year ago, there were Google revealed a couple of very disturbing CPU vulnerabilities, namely Meltdown and Spectre. And while Meltdown got more headlines because back in the time, the easiness of exploit with Meltdown was way higher than with Spectre, and there were actually very nice demos of hijacking passwords using a couple of JavaScript lines in your browser. Meltdown was actually relatively easily patchable, and in the course of the next couple of days, all the major operating system vendors released patches that actually, by sacrificing a little bit of performance, patched the problems with Meltdown. The second vulnerability that was released with Meltdown was called Spectre, and for me, this vulnerability, first of all, is much more dangerous, and second, um, is not uh, didn't go away, even now. And that's because Spectre vulnerability allows, by observing a perfectly valid code, allows the attacker to guess, to speculate on a certain behavior of this code in memory, and using this information, gain access to the memory areas in which they should not have access. And the key part of this sentence is obviously by observing perfectly valid code. Because what it means is that there is no way to write a code which will be uh, not valuable, not vulnerable for Spectre. You write the code by best practices, you use design patterns, your code is good and valid. And this is what makes it vulnerable with Spectre, because then attackers can speculate on how this code will behave on a processor level just by knowing which best practices you use. And that brings Spectre, I would say, how do I say it? Spectre class attacks to be inherently zero-day vulnerabilities. Zero-day vulnerabilities refer to for how long we know that that vulnerability exists before it becomes public. And the answer is, with Spectre, we never know. We only know that a certain valid code, a certain application, is now vulnerable after the fact, after someone discovers that it actually does some malicious actions. And that means that we cannot prevent Spectre-based attacks. We can only patch. And obviously, the faster we can provide an update, the faster we can provide a patch, the more secure our systems are. And that would be my third argument for liquid software and continuous update. So just to summarize, happier customers because they have features, happier customers because we solve problems faster, and happier customers because the systems are more secure. We can respond to 0 days vulnerabilities faster. Let's talk about what happens in the market today, what we actually see. We do see a bit, so and for that, for realizing where we stand now, it's good to take a cue from automotive industry. And you obviously know that in a lot of software discussions we use this analogy a lot. Obviously, all the Toyota manufacturing processes with their lean and Six Sigma and what's not, all comes from that. So back in the day, 100 years ago, even more by now, creating automobiles was a craftsmanship. Um, Artists or craftsmen actually created unique cars for their customers by order, and then Ford came with the revolutionary idea of a manufacturing, of a mass production pipeline. And this is where we actually started to satisfy the demand, to lower the price, and to increase the quality. And Obviously, the entire manufacturing line back then was completely manual, and today there are the same manufacturing lines are completely automated with robots and what's not, and they produce the cars. And this is kind of our analogy breaks a little bit, because after you got the car, which was manufactured in your pipeline, so we went through from development all the way to production, and you as a customer got the car, next thing that you do with the car is actually throw it away. There is no update process. You get a product, you use it, you get rid of it, and you get a new product. The difference between continuous delivery, continuous deployment, and all that, that's exactly what this analogy gives us, and continuous updates, is that in continuous update, your car keeps getting better while you already have it. And obviously, we see pioneers in this direction doing it now. Although Tesla won't get flying abilities anytime soon, but obviously its software is getting continuously updated after you already bought the car. So if you remember, when in the beginning you got Tesla with a pretty nifty driving assistant tools, like lane departure and adaptive cruise control, and in some point of time your car got updated to have an autopilot, and suddenly it got better without you getting rid of the old car and getting the new car. And now they are adding more and more features to this autopilot, all the way that the same Tesla you bought a couple of years ago and had just a couple of driving assistant tools will become a completely safe driving car without actually needing to throw it away and buying a new one. So this is the difference between continuous deployment and continuous update. And while I already mentioned someone that does it today, and that Tesla, there are actually, let's talk about where we stand now. So getting back to the Dora report, you can see here that elite teams do deploy multiple deployments per day. This looks a lot like Liquid software. Tiny updates, obviously, if they deploy multiple times a day, the changes cannot be big. Tiny and very, very frequent updates are going to production every day. And one of the examples of those, I would say, pioneers of Liquid software is Google. That's a slide from Swamp Up JFrog user conference last year. And from Google Keynote, and you can see here that they run 4 million builds per day, and they actually produce 2 petabytes of build outputs per day. And obviously those outputs go to production systems, and Google production systems updated hundreds, if not thousands, time a day. This is a Liquid software. And you can say it in a lot today, already today, that the version disappeared, and we have this flow in multiple aspects. So do you know the version of Facebook you see in the browser? Obviously you don't. And that's okay. That's a cloud software. It's get continuous updated, and the version's not of your concern, but it actually goes further. It goes, do you know the version of Facebook app on your smartphone? Well, if you set to auto update, you probably don't. It's getting updated behind the scenes, and it is actually always up to date without you knowing the version. And then you can say, okay, but this is a controlled environment. I have my App Store or my Play actually controlling the apps. So it's a little bit more like the cloud version. That's true, but it also goes to the browser now. Do you know which version of Chrome or Firefox are you using? They are also getting updated behind the scenes. And if you remember, Google switched to this ridiculous versioning scheme when each and every new update became a new version, and we were like, oh, what's going on? How suddenly my Chrome now gets a new version every month, and I used to be on Chrome 1.2 and then 1.3, but suddenly I'm on Chrome 49. What happened? And the result, and the answer is Google were preparing for continuous update. When the versions, when you don't know what the version is, the version can serve different purposes. Instead of being human readable that makes sense, well, version 2 is a huge difference from version 1, and version 2.2 is probably not a very big difference from 2.1. Now, when you don't know the versions and you don't care about the versions become something much more technical, something for the machines, something for different processes, and not necessarily a marketing tool. So this is why now Chrome is on version, I don't know, 50, 60, whatever it is, and no one actually cares because we don't care about the versions anymore. You can see this change from using the version as an anchor in human behavior, also in pricing models. So we used to buy a version of a software. We used to have, I don't know, like we would buy Adobe Photoshop version 3 and pay a certain amount of money for it, and it would be ours forever. And then Adobe would work on version 4 for I don't know how long, a year, couple of years, and then go and sell it to me as a new piece of software, maybe with a little bit of discount because I already have version 3. But generally they would come to me and say, here's version 4, buy it and own it. And we see that as we remove versions from being this incentive for human behavior, we actually change the entire business model around software as well. More and more companies switch from charging per version to a licensing model, which is more flexible and allow you not to care about the versions. One of the examples, and Java developers, software developers out there that use JetBrains product, that's an example of the company that switched from per version payment to a licensing. And what they say is, pay us yearly, and we will update your software all the time. When you will stop paying, you will be stuck on whatever version you got lost, and no new updates will come your way. So you can see that we changed the business model to support the notion of continuous updates as well. Let's talk a little bit about what it actually takes to liquefy your software and to make a continuous update possible. So let's talk, how do we update software, where it still holds us back, and what we can do in order to overcome it. And so operating system versions for our smartphones are still something that we download manually. And we are really not sure if you want to do it because, first of all, we will be without our phone or without connectivity for a certain period of time, all the way till the update will complete, because the updates are large. It's an operating system. It downloads the entire new version and then replaces it and what's not. And also, we are not sure if everything will work as expected. So actually, this morning I updated my Mac, and I discovered that a very important feature that I use a lot actually doesn't work anymore. And I have to say that I'm a bit frustrated about that. So next time my Mac will suggest updating its operating system, I'm not sure if I will want to do that. Another very annoying thing is the timing of updates. So I do have a smart TV that has a tendency to offer me an update every time I turn it on, which actually makes sense. The problem is I turn it on to watch TV, not to sit there and wait until it will be updated. So I never do it, and eventually the software goes out of state and becomes not reliable, becomes not compatible with the new applications that I want to install, and also might become vulnerable to security threats that were discovered in the software that I run if I don't patch it in time. And obviously, competitors that come with new versions can win me over. Although those features might be available on my smart TV, I will probably never use them just because I never update the software. And I never update the software just because of this usability bug of suggesting me an update just in time I want to do something else. So there are a lot of aspects, and that's obviously an example of a very, very bad timely update. So there are a lot of obstacles, but I want to talk to like usability, but I want to talk with you about another obstacle, which is for me is the most important one. And I'll tell you a story. Um, in 2007, Java announced a very, very big switch in their update policy. Before that, they released every 18 month, 12 month, and then 18 month again. And then we had Mark Reynolds announced, now we're going to release every half a year. Every 6 months, you will get a new version of Java. And now we are in the beginning of 2019, and we can look back and see how it worked for Java. And there are a lot of very good surveys about the state of Java, and you can see here a couple of them. The adoption of new version of Java, which is Java 9, Java 10, and everything after, did not pick up. The majority, 80% of the users still use Java 8, which was released before this switch to faster releases. And the question is why? Didn't we just say that people love frequent updates? Didn't we just say that it's good for everybody that the update will be more frequent? And um, why people don't adopt this very quickly? And to understand that, I want to go with you through a simple decision diagram on how we make decisions about updates. So let's say we have an update available on whatever it is, and then we need to decide if we want to take it or not. So first question is, do we even want it? Doesn't have any of the features that are of interest of us, or maybe there is a security update that we want, or anything else. Now, maybe there is nothing interesting there. And then we just say, okay, there is nothing, there is no reason for us to update. We are not going to update. But if we do want it, the next question will be, can we update it without risk? And here it really depends on the software that you update. Probably it's just a game on my phone. Why not? The worst case scenario, the game won't work. So if there are no higher risks, I'm ready to update. Now, if there are higher risks, the next question will be, do we trust the update to be in a good quality, or at least that we will be able to roll it back without any significant price to do that? If we do trust the update, we will update even if we have those high risks. And think about probably Mac OS operating systems a couple of years back when we actually were sure about the quality, and we knew that we can easily update our Macs without any risks because we had trust with Apple that they won't screw it up. If we don't have this trust, then the next question is how can we verify, or if can we verify at all? And here we're entering our example with Java. So when we are talking about updating our servers, our production systems of our software with a new Java version, the risks are extremely high. Those are production servers, and if something doesn't work with Java, if our code doesn't work, we're going to get out of business. Do we trust Oracle that Java won't break anything? I guess for the majority of us, the answer will be no, just because how high the risks are. Those two, the trust and the risk, are obviously tightly coupled. The higher the risk, the less we have trust. So just because the fact that the risk is so high, um, trusting the update blindly will be problematic for us. And the next question is, can we verify the update? If we just can't, or it's not worth it, or it's too expensive, we probably won't do it. So again, we go back to the release notes of Java 9, we look at it, and we're like, well, does it worth wasting tons of time and money to verifying the update? Do I have any critical features that I want to take? The answer is no. I will stick with Java 8. Now, if I can verify it and I want to verify it, then I will do this time-consuming verification. And only after that, I will update. And time-consuming verification will be stuff like staging environments, like copy of my production environments, like running stress testing and penetration testing, and generally tons of client-side acceptance testing before I'm sure that I can roll in production those systems in production. And this time-consuming verification is exactly where our continuous updates break. Because now, if I need to spend half a year in verifying a version of Java, what are the chances I will want to update new version of Java every half a year? What's the benefit for me? I just updated, and here is a new update. I am not ready. So when you hear that, and you can hear it both from vendors and from customers, we are not ready to take frequent updates, or our customers are not ready to take frequent updates, the problem is right there. The problem is that the verification cost is very, very high. And whose fault it is? It is always the fault of the vendor that failed to establish such a level of trust that we actually go here to we don't trust the update and need to deal with this dilemma of should I spend a lot of time verifying, or I will just abandon it and won't even bother. But then we go back to Dora and we say, wait a second, but there are companies that do deploy multiple times a day. How this decision diagram works when we have auto update with those companies. And then the diagram looks a little bit different. So first of all, no one asks us now, right? Either if we want the update or we don't want the update, we will get it anyway. The only difference is that if we are cautious, if we know about the update, we might consider the risk, and eventually we will update, just because most of the times we are talking about updates with very little risks. And those updates are very little risks for two main reasons. The first is, well, what's the worst thing that can happen if an update of Facebook goes bad? I mean, you will have some jumping when you scroll your Facebook feed, or I don't know, like posting to a Facebook marketplace won't work. None of them are high risk, and we are okay with those updates, knowing that even if something went bad, it will be fixed soon enough. The other reason why those updates are such a low risk is because they are so frequent. The scope of changes is so small that we can assume that nothing goes wrong, or because we know that the updates are frequent, we expect those problems to be fixed immediately in the next update. So this is how it's supposed to work and how it works most of the time. But even here, when we assume that the risks are very low, stuff happens. I don't know if you are familiar with what it's called the Albanian virus copy pasta. It's been a thing over the internet for a couple of years now. I think it's a great joke. Go ahead and read it. Basically, the idea is that because of the poor technology in a certain country, the virus from hackers in this country didn't actually manage to do any damage, and they appeal to the user of the computer to delete um, important files and forward other important files to the author of the virus just because the software is not good enough to do it yourself. Now, this might be a funny joke, but it comes with a personal story. Couple of years ago, I was on a trip to some conference, and my wife called me and she told me, Baruch, our kids sitting in the dark. I came home and the kids are in the dark. And I'm like, what happened? Do we have like a power outage? And she's like, no, the power is fine. It's just the internet that doesn't work. And the kids go like, Alexa, turn on the lights, and it doesn't work. So they just sit in the dark. Uh, and I'm like, okay. But what happened with the internet? And she's like, I'm not sure. I called our internet provider and they say that everything is fine. And then I said, well, probably will come back soon, and went to check my email. And in my email, I found this email. This is Albanian virus in action. So what actually happened is an update of Google Wi-Fi systems reset my router to that did a factory reset to the initial state it came from the store, and that obviously means not connected to the internet, and actually deleted the networks and what's not. And the problem is, what do you do in such a case? What Google can have done better instead of sending me this email? Well, go ahead and now reset your entire we reset your entire router, so you need to reconfigure it, and we can only ask you by email because we cannot connect to the router because we actually reset it. And the problem here is, as you see, it's not theoretical, it's very practical. How do you provide rollbacks in case that bad thing happen? And in this case, obviously sending another update that will fix this update is not feasible because there is no connection to the router, so they cannot push an update. And in this case, the solution will actually be, and it's true for general good practice that you can read more in the book, is having a local snapshots on the previous updates that you can roll back to in case that something bad happened. And this goes into how serious the company is about building this trust. So instead of the previous diagram, when we kind of assumed that there are no high risks, if now we know that sometimes it is a high risk, we still want to allow continuous update. And the only way to do it is by building the trust between the vendor and the customer. And this is done by number of ways. And first and most important is the assurance of the quality of the update. And assurance of the quality of the update comes in direct conflict with Seneca that said that to err is human. Humans make mistakes, humans allow bugs, humans don't test enough, humans don't test good enough, humans are not good in assuring quality that provides a blind trust. And the way to solve it is to take humans away from this process. Actually, welcoming our robotic overlords that know how to do everything better than us, and especially know how to perform repetitive processes in a predictable and repeatable way. This is where we need to step aside and let the machines take over. And you can see here that there are what we call the QA wall in our drive to continuous updates. Manual QA, manual deploy, continuous deployment, and continuous updates are all walls of manual tasks that we need to overcome. And those manual tasks become more and more complicated and more error prone with the rise of software complexity. And the way to solve it and to break through those walls is by trusting the machines more. Today, with artificial intelligence and with our research into how computers can help us more, this is actually possible. It also makes a lot of sense economically. It's actually going to save you money. In this graph, you can say that way back, humans were much cheaper than machines, and the amount of labor that humans had to do was much lower. Today, with the complexity of the software, the number of times the task runs obviously goes up, the cost goes up, just because both humans are more expensive than they used to be, and because they need to work much more because of the software complexity. Automation, on the other side, becoming extremely cheap to the level of when we say the storage is now free, and what we mean is that the adding more storage is so cheap that it actually doesn't matter. And the same with computing power, the same with memory and other computing resources. So now we see that it's much more efficient to automate. And that's right that automating requires an effort. But after that, because we run it so many times, it's so cheaper to automate than to employ manual labor. So it's cheaper, it's more effective, it gives better results. And if you are in doubt that our software is getting complicated, that's how we see it. And a good indication of the complication of software is the amount of binaries that we need to deal with. And JFrog, we deal with binaries, so this is what we know to measure. Back in the 2000s, we started with this trend by introducing agile and continuous integration. When we actually start to care about integration and about artifacts from different and about intermediate artifacts. Now we not only care about the releases when we integrate with others, but on our way to release, we start to care about different intermediate results. Continuous delivery, not only we care about those results, they actually go to production now, so we care about them much more. Infrastructure as code, now our servers, our software as well, which obviously adds to the complexity of the integration between different parts. Microservices, we have a lot of tiny pieces of software that need to be integrated together. Docker, serverless, and IoT. IoT brings an unprecedented level of combinatorial complexity when we have different contracts, devices, users, servers, networks, and locations, and all that needs to be aggregated together. And the more complicated systems we build, the more points of constraints we find. And this goes to another great resource, another great book that I highly suggest you read or listen, and that's The Goal by Eliyahu Goldratt. It's actually a 30 years old book now, but it's still extremely relevant to what we are doing now, and especially considering how well the analogy from manufacturing works for software production. One of the main concepts of the goal is the theory of constraints. And theory of constraints basically means that in the second you introduce a single constraint on your system, it propagates through the entire system. And you can see here that we managed to build an extremely automated pipeline of software delivery of liquid software. Software flows through the pipes, and we have automated validations and verifications. And then in the end of this process, there is one tiny manual task. And this one tiny manual task brings the entire flow of our software to a halt and introduces the something that will kill the entire liquid software concept. So we're approaching our time. So just to summarize what it will take to take us through this last mile from what we are today to actually continuous updates. As as I mentioned, trust and security are extremely important. And trust and security are built by production a stellar software quality. Stellar software quality can only be achieved if we automate as much as possible and delegate the QA tasks to our machines. There are some aspects which are harder to automate than others, and there are some aspects in which human expertise is required. But still, human expertise should be concentrated on building the process of quality instead of assuring the quality of particular products. So we invest in the process, we invest in automation, we invest in the system, this knowledge that only humans possess. And then our system actually can persistently and repeatedly implement those checks on the software that goes out. Zero downtime is another very important aspect of continuous updates. Obviously, if we are going to update our software extremely frequently, we cannot take it down for these tasks. For now, the only reason for updates which require downtime is that those updates are rare. And rare means maybe you can take a banking system down every night for update just because the banking hours are limited to day only. Or rare means once a year you update your Java version and you announce in front 2 hours of maintenance that your systems will be down. But both of them are unacceptable. First of all, because of globalization, there are really no times when you do no business, but also because we want to push to much more frequent updates than once a year, and even more frequent than every night. If the software is updated continuously, obviously downtime is not an option. If you look at the book, there is an entire chapter of a very technical explanation on how to achieve zero downtime updates with microservices. Obviously, Liquid Software is not the only source for that kind of information, but it's just convenient to be there, and it's kind of our proof that it is possible to do. It's a good place to start, and obviously you can extend your research beyond that. Rollbacks, their availability and their quality is extremely important. Generally, your ability to restore service after a bad update is not um, is not less important than your ability to provide new features. We spoke about that in the context of Dora, and we spoke about it in the context of Google and their router update. But basically, what I want to say, this is another very important aspect of investment that includes also, if you already able to release continuous updates, your rollback is just another update. But also you need to remember those situations when you can not actually get to your device through connectivity, and it should be able to detect the problems and revert back to a locally stored rollback. And transparency, this is another very, very important aspect that build trust. If your customers know how you create updates, if they know how the software is validated, how the software is built, how you plan to provide the zero downtime and the rollbacks, this is what builds trust when the customers feel comfortable enough to eliminate the acceptance checks, and by this to truly allow software updates. So with that, I will be more than happy to answer any questions, and I actually do have a question for you while you type your questions. So I will launch this poll, and that's actually what kind of webinars you would like to see in the future. It's obviously very important for us to understand what you care about in order to provide better content for you. And feel free to ask any questions in the Q&A tab regarding Liquid Software and continuous updates. Okay, so the question, just kind of expected, is where can I buy the book? And you see here on the screen, liquidsoftware.com has a link to Amazon when you can buy the book. And kind of related question, another one is there an audiobook? The audiobook is actually in production now. We finished recording and finished reviewing it, so I expect it to be available in Audible very, very soon. You can always come back to liquidsoftware.com. We will announce the availability of the book there. Another very important feature of liquidsoftware.com is a blog that we, the authors, post different ideas around Liquid Software and expanding on what's in the book. So don't forget to sign up for the blog updates as well. Well, I guess there is no more questions and we are just in time. Thank you very much for attending this webinar, and I hope to see you soon in the future webinars of